In your electrical installation, you have a live wire, a neutral wire, and a earth wire. So these three wires have different purposes. We have this live. Everybody knows what the live does, because when you touch this one, you feel like somebody has beaten you on the head. If you have ever got an electrical shock, you understand what I'm saying. Then this one provides the return of electrical supply, and it completes the circuit, and therefore the loads that you have in your house functions as they should. Then we have the last one, which is seldomly talked about, yet very important. But before we get to that point, let's ask ourselves something. What happens when the live wire, which is, we all know is dangerous, touches the metal casing of your fridge? So the live wire has touched the metal casing of a fridge, and you happen to be around that place, and maybe for some reason you touch the fridge. So what happens to you? So we all know, utasikia hivi kwa akili. And technically what that is an electrical shock. So what does electrical technicians do to protect you? So they install an earthing system. So this earthing system protects you from electrical shock. But disclaimer, it doesn't exclude that little tingling that you will feel as a result of touching the live wire, but it will not be as bad. It will not be as bad as you touching the live wire without the earthing system. So the $1,000,000 question is, how does the earth protects you as the consumer? So let's look at that. So basically, the earth, we have a live wire coming to your load. This is live. We have a neutral wire coming to your load. And let's say this is your load and it's metallic. Yeah. So the load that you're having here, the load is metallic. So you expect electricity is supposed to flow through the live wire and return through the neutral wire, and therefore your load functions just fine. But what happens when now there is a fault and your live wire is in contact with this metallic part of your load? It means you are likely to get an electrical shock. So what does we do? So you realize that you as a human being, when you stand, okay, so we have live wire, we have neutral, and you have our load, and we have you, Kamau, standing over here on the ground. All right, so this is neutral, this is live. So while you're standing at that point, if you touch this load, when there is a fault, you get an electrical shock. So what does the earth do, and how is it connected? So the earth is connected to this casing and it's grounded. So the earthing symbol is drawn like this. Okay, so let me change that color. So it's connected to that symbol, that material like that, and it's connected to the ground. So you realize you are stepping on the ground, and this earthing rod or earthing wire or a protective conductor is also connected to the ground. So this one, in case there is, so for the load to work, or rather for electricity to flow, or rather electricity always flow in a path that is complete. So you see that you have a live wire here, and now that the live wire is in contact with this load of yours, and you also are in contact with this, electricity is going to be provided by an alternative path to ground. So what electricity is going to do, and I like using this analogy, is that the electricity will do some mathematics. Yeah, quote unquote, I'm personifying it. It's going to do some mathematics between this cable here that is grounded and this human body that is here. Which one of the two has higher resistance? So resistance of the body or resistance of the wire. So electricity will always take the path of least resistance. Path of least resistance. Resistance. And between you and the wire has very little, especially if it's copper, it has 0.0075 ohms per meter, and you have a resistance in the in the tones of mega ohms. So you realize that electricity will likely go through the earthing rod rather than your body. And basically that's how the earthing rod protects you from an electrical shock. So in the next video, we're going to look at different systems, earthing systems, how they are built, what advantages do they have over the others. Some are grounded at the source, some grounded at the load side. So we're going to look at that individually in the next video.